Good morning, everyone. My name is Saumya Mehrotra, and I'm here to present HR 2227, Strengthening the Resiliency of Our Nation on the Ground Act, also known as the STRONG Act. I would like to thank our faculty advisor, Professor Howard Apsan, for his guidance, my entire team, especially Nirda and Kevin, for their help. Today, I will summarize all the topics we've covered in our summer workshop. I will start by describing the problem that the bill addresses, followed by the solutions mentioned in the bill. I will refer to some uncertainties and controversies that surround these problems as well as the solution, followed by how is it that we can measure the success of the outputs of the bill. I will conclude and lay out the next steps. Many of us have experienced extreme weather events in some form or the other throughout our lives. These extreme weather events significantly impact human health, life, property, as well as economic productivity. We may have seen images like these, images of destroyed homes and devastated communities on TV. The unfortunate fact is that this is not distant reality. This is a map that was released by the National Oceanic and Atmospheric Administration. It shows the various extreme weather events that occurred in 2015 that incurred losses worth more than $1 billion. As you can see, there are multiple billion-dollar events. And also they range from hurricanes, floods, tornadoes, extreme heat, drought, and extreme cold. My colleague Jason in the midterm briefing spoke about some of the scientific reasons behind the formation of these events. They range from excessive or inadequate precipitation, snow melting, and variation in jet streams. We continue incurring significant losses with each of these events. And also there's the fact that it's been predicted that the frequency and intensity of some of these events will increase in the future. So what is it that we can do? How is it that we can maximize the efficiency and effectiveness of the existing resiliency efforts? The STRONG Act says that it's important to bring together all the tools, resources, and stakeholders involved in resiliency efforts under the umbrella of one national-level resiliency strategy. I will explain the implementation framework of this STRONG Act in the standard Plan, Do, Check, Act model. In the planning phase, there will be the formation of an interagency working group that will consult stakeholders from various levels of the government, as well as different government agencies and experts from different sectors to conduct a gap and overlap analysis of existing efforts. Based on the results of these analyses, they will devise a national extreme weather resiliency action plan. This action plan will be backed up by the creation of a data portal that will house tools and information that can aid in resiliency efforts. In the check phase, which is the monitoring and evaluation phase, the bill calls for the submission of annual reports to track the implementation of the bill. Based on the reports, the committee or the working group will act on continuous improvement of the proposed solutions. Resiliency in action comes in two forms. One is infrastructural solutions, and the second is predictive modeling. Predictive modeling can come in the form of emergency response alerts, which is the warnings that the public receives for imminent threats, and long-term data modeling. An example of long-term data modeling is there as the map of South Carolina, which shows zones in the state with high flooding risk during storm surges. This tool can be used by policymakers to devise strategies on infrastructural development to identify high-risk areas. Infrastructural solutions do not just deal with creating structures that can withstand extreme weather events as and when they're happening, but they also deal with long-term resiliency. As you can see on the slide, each type of extreme weather event has its unique set of solutions. I will specifically talk about the case of Brooklyn Bridge Park, which is a park in New York, and some of you may have been there. When the park was conceptualized, the design team especially wanted to create an area which could withstand the impact of weather events like storms and major floods. When Hurricane Sandy occurred, more than 400 parks in New York City were either flooded or damaged. and Brooklyn Bridge Park was not one of them. In fact, many other coastal areas like the Ellis Island and the Liberty Island faced significant damages, which in fact totaled up to $59 million. The point of this case study is to show that building resilient infrastructure in urban landscapes can help reduce economic loss due to property damage. These solutions, however, do not come without their own set of uncertainties and controversies. At the very heart of the problem is the fact that extreme weather behaves in erratic manners, which makes it hard to predict their track and intensity, and hence the solutions devised. Different predictive models can predict the same event in different manners. As you can see on the slide, there is a graph that shows the tracks that were predicted for Hurricane Sandy. The black line shows the actual path that Hurricane Sandy followed, and there were two models that did not even predict a landfall. The closest to accurate was the red line, which was the model devised by the European Center. This variability in predictive models also trickles down to variability in infrastructural solutions, where it affects their efficacy as well as their cost versus benefit analysis. A classic case of this is the construction of dams, where we're still unsure whether the financial savings are actually higher than the costs of human displacement and ecological destruction. These uncertainties can be managed by measuring the success of the outcomes of the bill. The STRONG Act aims to minimize economic loss as well as reduction in human lives. And hence, it makes sense that the outputs of the bill are improved predictive modeling, better infrastructure, and increased warning time. The outputs of the bill flow naturally from the outcomes. With continuous measurement of success, we can ensure continuous improvement in short-term and long-term resiliency. In the last 30 years, we've lost more than $880 billion in standardized losses due to extreme weather events. More importantly, we've lost more than 16,000 lives. FEMA says that it makes economic sense to invest in hazard mitigation. It says that for every dollar we spend on hazard mitigation, we save an approximate of $4 in future losses. As we have seen through multiple examples, investing in proper mitigation measures like improving infrastructure, predictive modeling, better communication and coordination, we could anticipate fewer deaths and a dramatic reduction in property damage and economic loss. This is a nationwide problem, and it merits a nationwide solution. At the end, I'd just like to mention how great an experience we've had working on this project together as a team. We came together to understand the scientific problems as well as the solutions in extreme weather resiliency issues. I'd like to especially thank Professor Howard Apsan, not just for his excellent mentorship, but also because he introduced us to certain very exciting conversations happening across the city in extreme weather resiliency efforts. We will submit our report next week, and I do hope all of you will read it. Next semester, we look forward to working on the implementation analysis of the bill. Thank you very much for your time. I will now take questions.
First of all, thank you, Saumya. That was great. I just had one question about your example with the green infrastructure. Does the bill specifically draw attention to green infrastructure projects as a possible solution, or does it leave all of that up to the working group?
It does leave most of it up to the working group because they will conduct that gap and overlap analysis and other analysis, but it does briefly mention that green infrastructure can help mitigate the impacts of extreme weather.
All right, thank you very much.
Thank you.